then what is that is happening? So similarly, heat transfer also, we have a situation where there is an unsteady heat transfer, or what we call as transient instant. Unsteady means it depends upon time. So with time, how the things are changing. Some of the examples, why do you want to do? Many of this example you may face day in day out. So when a hot cup of coffee is served, when it's straight away taken from the stove, if I give you a coffee, are you able to drink it? So when do you think you are able to drink it? What is the temperature you require for drinking coffee? This is a good question. Chala good. I mean, it is 90. Chala you won't be able to because it won't taste better. At 90 degrees, as soon as he makes coffee and will give you coffee or tea, then what happens if it defeats your tongue will burn. So there is some temperature at which you will be able to drink. Approximately, what is your guess? What should be the temperature of the coffee in your drink? 50, 60, 70, 80? How much? Oh, I tell you, what is it? It has got to be warmer than body temperature, right? Body temperature is 37 degrees. Approximately, what is the temperature at which you would like to drink? Usually it will be between 50 and 50. Anything, or people can drink up to 60 also, but it will take long. So you have to wait until the coffee cools down from 90 degrees to 60 degrees. So how long is it going to take? Then common sense tells you that how big is the cup, what is the specific heat, whether it is made of stainless steel, whether it is made of porcelain, or how much of coffee is there, and what is the temperature at which you stand out of the kettle or coffee maker. Okay, the second situation. Normally you take a boiled potato. Okay, are you able to eat it straight away? Boiled potato, to take it out of the pot, and then are you able to eat it? You are not able to eat it because you have got to wait until it cools. Many times you will see that when you take boiled potato and bite it, the surface is cool, but inside is still hot. That's why you take potato, you bite it, keep on saying that, right? So inside the temperature is not changing, so it is changing with time. So how long does it take for the boiled potato to come to a temperature where you are able to eat it? Okay, that is second question. Third one, this is more like, let's take a piece of red hot iron and use a colony. There are so many people are colony. What is called colony? What is called there?
కొలిమి అంటారు సార్, తెలుగులో కొలిమి అంటారు.
ఏం చేస్తాడు అండ్ తీసి కొలిమిలో పెడతాడు కదా. కొలిమిలో పెట్టిన తర్వాత ఎంతసేపు అవుతుంది హీట్ అవ్వడానికి? ఎందుకంటే రెడ్ హ్యాట్ అయిన తర్వాతనే ఈ కెన్ బీట్ హీట్ కదా. హీట్ అవ్వడానికి ఎంతసేపు అవుతుంది? అది వన్ హీట్ తెలియదు, కానీ దాంట్లో లోస్ ఫ్రమ్ ప్రాక్టీస్ ఇట్స్. ఆ కొలిమిలో అది కొట్టిన తర్వాత బయటికి తీసిన తర్వాత ఎప్పుడు దాన్ని ముట్టుకోవచ్చు, అంతకుముందు ముట్టుకుంటే చేయగలరు. So how long will it take before actually you are able to touch it? Again, example is you can touch it only when the body is somewhere about 40 to 45 degrees or something. If you want to accelerate the heating, you only just 30 kilometers per minute. Needle munchina tarvata vettana bite this it is still hot, you allow it to cool down for some. So these are all situations where actually you face day in and day out. From the heat transfer point of view, we should be able to say, listen, okay, boiled potato స్టవ్ నుంచి తీసిన తర్వాత 2 నిమిషాల తర్వాత తింటే నీకు పర్వాలేదు. దట్స్ వాట్ యువర్ మమ్ అండ్ డాడ్ might have told you, don't eat it, or when you become older and you have children, you tell your child, look, don't eat it so much, it will be very hot, wait for some time. So these are all the situations where actually these are all the practical examples of unsteady heat transfer or transient heat transfer. So all these things you have to know is how heat transfer occurs, but it essentially depends on how heat transfer occurs. Let's say because now there is a vada. For example, you take vada, you go to vada fry చేస్తుంటారు, బజ్జీ రన్ చేస్తుంటారు రోడ్లో. వాళ్ళు బజ్జీలు ఫ్రై చేసి ఇవ్వగానే మీకు తినగలరా మీరు? యూ వోంట్ బి ఏబుల్ టు. సో వెయిట్ చేయాలి. సో ఎంతసేపు వెయిట్ చేయాలి? సో వాట్ ఇస్ డిపెండ్ అపాన్ బజ్జీలు ఎంతసేపు తర్వాత తినవచ్చు, మిరపకాయ బజ్జీలు వచ్చి ఎంతసేపు తర్వాత తినవచ్చు, బయటికి తీసిన తర్వాత అప్రాక్సిమేట్గా 10 నిమిషాలు, 20 నిమిషాలు వెయిట్ చేశారా? అవునా? దాన్ని సో ఓకే, ఆ 10 నిమిషాలు దాని పై డిపెండ్ అవుతుంది. వాట్ ఆర్ ది ఫ్యాక్టర్స్ ఆన్ విచ్ దట్ 10 minutes will depend? సో ఇఫ్ ఇట్ ఈస్ వెరీ స్మాల్ వడ, ఫర్ ఎగ్జాంపుల్ చిన్న బజ్జీ తీసుకుంటే చిన్న బజ్జీలు అంటే మిరపకాయ బజ్జీలు ఆలుగడ్డ బజ్జీలు చిన్నగా ఉంటే అది కొంచెం చేసుకోవచ్చు కదా. ఇదే మిరపకాయ బజ్జీ అయితే కొంచెం ఆలస్యం ఉంటుంది. అదే బోండా అవన్నీ ఏమి చేస్తే ఇంకొంచెం పెద్ద బోండా అయితే కొంచెం వెయిట్ చేయాలి. సో దట్ ఈస్ ఆల్ కామన్ సెన్స్. సో ఇన్ టెక్నికల్ టర్మ్ వాట్ ఈస్ ఇట్ డిపెండ్ అపాన్? Basically it depends upon the mass. So how big is your vada or bhajia? What are the contents? Again, how much is the specific heat of this one? And what is the temperature at which is there? So it is mass, the specific heat and temperature. These are the three factors which are common sense choice. Same thing about boiled potato. If you boil potato is bigger, I have to wait for longer. If it is a smaller potato, you can what do you call that? Dum aloo. It's a small whole potato, you make dum aloo. Okay? So then actually you have to wait for a shorter duration. So it depends upon the mass and also the surface area that's available for heat transfer, the specific heat. Okay? This is the background. Okay? Is everyone on the same page? Now, shall we get into some kind of a real heat transfer from now on? From common sense to go to heat transfer. Okay. The type of equations here commensurate with common sense test. How much of solid liquid is contained? What is its temperature? What is specific heat? This is what actually I have mentioned. This common sense test. How big is the potato? It depends upon the volume, it is density, it is essentially mass. And what is specific heat? What is the rate at which you can produce heat? That's all. So the energy balance. Now this way we are getting into hardcore heat transfer from the water. This all common sense is over. Now we go to hardcore heat transfer. The transition of that one is common sense tells me that rate of heat removal here by convection when you are taking the potato and leaving it in the air, the potato is going to lose heat by convection to the ambient, and at the same time it is getting cooler. So the rate of heat removal normal by convection. That should be all equal by radiation also, but in this particular situation, transient heat conduction will just restrict to only heat transfer by convection from the surface. Radiation also is possible, that only complicates the matter. As I told you, you are all in only second year engineering, so you have radiation, you have highly non-linear boundary condition, that makes life more complicated. Most of you will get scared of heat transfer, we don't want to do that. So we will restrict it. So that should be able to rate at least the energy, decrease of energy. So if more of heat is transferred from the potato, so the faster it will cool down. That means what you do? When you just leave the potato and leave it on your plate, it takes more time for it to cook. What do you do if you want to do it fast? If you coffee that chala veediga coffee you just allow it to okay. You blow on the coffee cup, you blow on the potato. Common sense again. Endu blow chestar? Endu blow why? Blow cheyakunda this is forced convection. So natural convection heat transfer will be heat transfer coefficient very small, it will be not more than 5 or 10 watts per meter square. Whereas if you go forced convection heat transfer, locally you can go up to 15 or 20, it will cool faster. Same thing about if you buy American, but you buy this one, again you apply cools faster. Okay, let me ask one more question. Again, common sense. Bajji petti తీసుకున్నారు హాట్ గా ఉంది. What do? You give on continuously blow చేస్తారు. So whether you do which one you do? The second one. Common sense. And common sense, you know why you are doing it. Why are you doing it? అందరూ చేసే పని మీరు రోజు అక్కడే హీట్ ట్రాన్స్ఫర్ ఉంది. That's very heat transfer. Okay, that may be too far-fetched at the moment. I will give you an example. When you take anything, material, when you blow, fluid is also a solid. When you are blowing, you just not blow. Go to the garlic and make it. Whenever there is a solid on which a fluid flows, what happens is there is a boundary layer forms on the surface. Within the boundary layer, the heat transfer is only by conduction. There is no convection in the boundary layer. Outside the boundary layer, there will be. When you blow, the air is an extremely poor conductor. Thermal conductivity air is no more than 2.0 not the voice per meter cube. So though the boundary layer is very thin, the heat has got to transfer from the boundary layer. So when you stop blowing, what happens is the boundary layer is broken. So when you blow it again, the entire fluid is able to get in touch with the hot surface. That's it. Just frequently. Then of course, if you do it too frequently, it's good. But only thing is you will get tired. You will get too tired, you need more purchase than Okay, fine. Going back to the heat transfer. Now, the rate of energy removal is nothing but heat transfer. Now, this is actually my vada. And I have put a small role in that one because nowadays what is happening, all these fellows they are getting very smart. They want your vada to look bigger, but they make the whole also bigger. So the total amount of mass is reduced, the quantity is reduced, he charges the same amount of price. And also, but in a way it's good for you because there is more heat transfer surface available for its cooling. But you pay money for it. Okay, this is it. This is my product. This is the hole that is in the center. I have made it bigger. And outside there is actually a film which actually, that's what I mean, some kind of clay to do heat transfer. So let me say this temperature of this one is T. Ambient temperature at far away we call it as T infinity. Obviously we know that the heat transfer is accurate. Then the heat transfer for the surface area of vada and then heat transfer coefficient multiplied by the temperature of this one. And what is happening? This temperature itself is changing. That's what we have to keep in mind. That's what is the whole idea we want. So that should be equal to rate at which the energy is getting. So vada has the amount of energy and rate tau. Actually, I use it for time because instead of a small t, you can get some people use small t for time. The reason why I use tau is simply because the small t is also using for temperature. Okay, so that people don't get confused about that one. I am using tau here. And that's also so now see what we are doing as again. Let me switch to thermodynamics. The energy of this one comprises of three things. One is what is called internal energy because of its temperature. Second is potential energy, kinetic energy. Let's assume that మన చేతిలో ఉన్న వాటర్ పరిగెట్టడం లేదు. So kinetic energy is zero. So it's always at the table, it's not moving. So the potential energy also is zero. ఈ రెండు తీసేస్తే మనకు అంతే internal energy మాత్రం. So CP. So CP times delta T. Of course, I don't have to have CP when it is a solid. There is no difference between CP and CP. Okay. So you can actually substitute you will see that I will remove P. Basically, I am writing VCP. So this mass is nothing but now. Again, common sense, mass is nothing but density times volume. Density times volume. Why did I put the negative sign there? Why did I put the negative sign there? The idea? Come on, you people know. Why did I put it? Because the temperature is decreasing. So dt by dt, d tau will be negative. So because of the negative, that makes it this quantity will be positive. So if you want this, d is greater than d infinity. So h cannot be negative, area cannot be negative. So the left hand side of the equation is actually positive. So in order to get that one, I have to put dt is this. So that temperature dt by dt will be negative. So this negative sign takes care of that's why we have the negative sign. Okay, right. The negative sign means because this is of time, of course, I have written there. Now, AS is now I am going to concentrate more on vada because something that you know every day I can make it vada, so you all people like it. Okay. So A is vada of iron piece and B is this volume. Now what we do is again we do a little bit of auxiliary here. So every time writing T minus T infinity, although heat transfer people are very basic. We don't want to put too many things on the paper so that our pen paper pen. So what we do is we call the theta, which is actually T minus T. So when you take dt by d tau, it will be simply nothing but d theta by dt because if you differentiate this, differentiation of this will be 0, it will be d by d tau. So net AS times theta, theta times minus rho times CV, C times D, and d theta by dt. Or I will also do this simply from now on. Okay. Up to this is common sense. Next, this is heat transfer. Then this is understanding the heat transfer from here to the mass. Okay. I am expecting that all of them know mass. I asked you to brush up your math. So here is the logic. What I am doing is theta by theta is this there. In other words, the H as negative side of this compound. Negative of H times AS divided by rho CV. If theta would be divided this way. So this is what we do. Okay. Now, that integrate here. Okay? Chadam, can you write it? Integrate here. In low, none of them are functions of time. Heat transfer coefficient is not a function of time. Yes, basically is not a function of time. Density, specific heat volume, none of them. So all of this quantity can be pulled out. So when you integrate it, what we get? Integral of d theta by d theta.
Log theta is equal to
Okay.
rho CV into
What's integral of d theta by theta?
log
Okay. Alright, so what do you get? D theta by integral of d theta by theta is log theta. That should be equal to log theta should be equal to yeah. Constant better one, constant integration is a constant unless you are integrating the next step primary. Okay, got it? Plus a constant. Don't forget constant because when there is an integration, there has to be always a constant. And the constant, so because we call the, for a differential equation, we call two types of boundary conditions. When it is a space domain is concerned, x, y, z, boundary conditions. When there is a time is not like here, tau number, then we call it initial condition. So it is, ఇనిషియల్గా ఏ టెంపరేచర్లో ఉంది 100 డిగ్రీలో ఉన్న 120 ఎందుకంటే ఆయిల్లో ఫ్రై చేస్తే ఇట్ విల్ మోర్ దాన్ 100 డిగ్రీస్ వాటర్ బాయిల్స్ at 100 degrees oil boils at little bit more, that's why you instead of boiling, instead of frying in water, you fry the butter in have you ever think of what are being fried in boiled water? You won't eat it, right? It has to be fried only in oil. So why do you fry it in oil? Because oil boiling point is higher, so you can fry it, but when you get this crisp boundary, so you can't do it.
But dahi vada is soaked in water after frying.
You get the porous structure, you want dahi to go inside the juicy taste. Anyway, okay, that's your. So this will be, guys. Many of you, I find that you still weak in integration. I told you many times about the question of your calculus. So if you don't do that one, There are going to be a lot of problem both with thermodynamics and heat transfer. You will find it very difficult. Okay, please brush up your calculus. Okay, again, I'm insisting once again that day when I talked about isothermal, what the integral of dV by V, I saw more blank faces. At least now, at least 50% of people they know that integral of d theta by theta is nothing but ln of theta. Okay, then this negative of h is this theta because this becomes a stop. That's it. So ln of theta should be equal to this whole thing. Okay, let's go to next. So ln of theta should be minus h here should be plus constant c. Let's call the constant. So let's call the constant c1. So when we need the initial condition, that is at time t is equal to 0, we set the bottom was 100 degrees. So let me call that one as when the object is at temperature time t is equal to 0. What was the temperature? Right, like I told you, heat transfer is over. Then the basic differential condition now is all algebra, calculus, whatever you want to call it. Okay? The heat transfer is over. So whether or not theta, so you have to find out. So let us say initial temperature is Ti. So Ti maybe if you are talking about what are initial Ti temperature maybe 100 degrees. Theta I should be equal to theta I is equal to Ti minus T because we define theta as T minus T infinity. So initial temperature, initial theta I is the initial condition. It is just simply Ti. I stands for initial condition. Minus T infinity is the finishing of temperature. So simply when the tau is equal to 0, so ln of theta I will be equal to constant C1. ln of this constant C1 is equal to ln of theta. Then just on the ln of theta equal to plus ln of theta 3 up here this color. Then ln of theta minus ln of theta I. So if there is a difference of two logarithms, what is the condition? Logarithm of A minus logarithm of B should be equal to log of A by B. Okay? You understand that? Log A minus log B. That's what we have done. Log ln of I should be equal to the negative of top. Or then you just if you get a log method and maybe I'm more comfortable with exponential because theta is I want explicitly of nature. Theta by theta will be equal to simply exponential of e to the power of minus this whole thing. The multi much that now that we are what theta multi not to I'm not again writing it. Theta is nothing but t minus t. That's how we defined it. Theta I is Ti minus t into b. So that should be equal to very simple. That is actually the solution. So ఎంతసేపు అవుతుంది కనుక్కోవడానికి వెరీ ఈజీ టు సాల్వ్. దీనిలో ఏది అనుకుంటాం ఎంతసేపు అవుతుంది ఏ టెంపరేచర్ మనం తినగలరు ఈ వాల్యూస్ అంతా మన దగ్గర ఉంటే క్యాల్కులేట్ చేయొచ్చు. ఓకే చేద్దామా మనం ఓకే లెట్స్ సే ది what outer diameter 80 millimeters at the bottom 80 millimeters. I think this normally is that what you get in that time in shop or banana shop you get about this. Okay, now the initial inner diameter is about 100 mm. మధ్యలో బొక్క పెడతారు కదా అది 10 mm బొక్క పెట్టుకుంటాం. Okay, so the thickness of vada I take it as a hollow cylinder. Thickness of vada is 20 millimeters. That's why we pay about 20 rupees for that. 20 or 21 rupees. Okay, every time it goes 20 millimeters. We assume that it is like a hollow cylinder. Right, then volume cut. Vada volume. Like a number itself, but I have you have to check and get me that number. How do you calculate what a volume and what a surface area can calculate here? How do you calculate what a volume? It is a hollow cylinder. So it is surface area times height. So surface area at the top and bottom will be t square outer the outer square minus the I square. Guys, if you don't know how to calculate the surface area of outer cylinder, I think you guys will have a lot of time doing this. I'm going to answer. I'm going to title. That was calculate. But remember, following set and you have to take out the volume of whatever the power basis. So what is the surface area of this one? This is this area, out of that we will take out that area, continuous. So that is the surface area, then multiplied by the height, that will give you the value. Why don't people take it time? It is pi by 4 times 80 millimeters square, pi by 4 is square. Out of that you have to take out pi by 4 times tan square. This will take surface area of the and multiply it with volume. Surface area Okay, you can sit here. Move here. That is not that area. I'm feeling as they are not gone to that area. Don't go with that number. It's actually final number. Copy what that one is. Volume to the calculate. And 9924 by this is not a AS will go to the big data.
వచ్చిందా వాల్యూమ్ ఆన్సర్ వచ్చింది అక్కడ రైట్ 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 ఇది వాల్యూమ్
minus 5/4 of 10 square. But much of then approximately 98.96 అక్కడ లేదు బాబు ఆన్సర్ మీ క్యాలిక్యులేటర్ మీ దగ్గర ఉన్న ఆన్సర్ అక్కడ లేదు అక్కడ ఆన్సర్ లేదు నేను అక్కడ ఆన్సర్ పెట్టి మీరు కాపీ కొడతాను మీరు గంట కట్టాలి సిలిండ్ ప్లస్ సర్కిల్ ఏరియా తెలియకపోతే సెకండ్ ఇయర్ ఇంజనీరింగ్లో చాలా కష్టపడతాం బాబు ఇంజనీరింగ్లో తొందరగా నేర్చుకోవాలి కష్టం చేయాలి దాంట్లో ఇష్టం బ్రౌజింగ్ ఇంటర్నెట్ స్టడీ మ్యాథ్స్ ఇదంతా హై స్కూల్లో నేర్పిస్తాను 9th and 10th స్టాండర్డ్ నేర్చుకున్నాను ప్రపంచంలో ఉన్న అంత పెట్టి తీసుకుని యూనిట్స్ ఇంపార్టెంట్ అమ్మా can calculate surface area. How can you do that? Because you got water. So there is surface area for the The pi by 4 इसको मुंदे कटे Now it's only a question of using the calculators. I think I conclude that degree of mathematics, degree of mathematics. So unless you give pressure, I think so final examination on only everything is mathematics will be the questions. Unless they are through with mathematics, they won't be able to get through the exam. There will be a lot of integrations, differentiation, algebra, everything. How many meters squared? Meters squared convert change. Okay, there is one thing I have forgotten to add that one also. Plus the central pole also that we will see. So that will be 5 by 4 and 7 by 2. Times the area will this also will be seen. This area also will be seen. So but that will be very small, so that's why I ignore this piece. If you don't make proper calculation, you will be again your numbers will be wrong. Okay. Which is that 55.5 10 to the power minus 4. That is the number we should get is 37. Yeah, that's just the number. Time 11:69. Faster. Okay, guys, I think I will take this one and I have to get through this one because, as I told you, please have to do it. Next class, I'm expecting that all of you will be thorough with the areas, volumes, integrals, and all those things. Otherwise, I tell you, I'm not really scaring you. Second year engineering, not playing that much of mathematics is really a crime. In the first place, you should not do it. So, I think please brush up your basic. If you don't know 5 by 4 d squared is the area of a circle. Someone is, as I was telling me, what is the area of circle? He was telling me 2 pi r. It's different area has units of meter squared. 2 pi r has got only units of only meter. You must know the difference between perimeter and volume. Perimeter, surface area, volume. Please brush up your knowledge. You are going to have a hell if you don't understand. Let me tell you again. I don't mind scaring you. The reason I am scaring you is simply because you got to know this. Without that one, you will have a hell. I can guarantee that one. Okay. Okay. Now we have got the P, we got the AS. Let's say that the heat transfer coefficient is 10 watts per meter square because I am not growing across. Usually natural convection heat transfer will be about 10 watts per meter square. So the density of water, when you put water in water, what is it float or is it sink? Right? Huh? You put it in water. Right? Does it float or does it sink? It floats. It sinks. No. Woman, of course, you don't do what I do water. At least what I do, you put it in butter with water.
Initially it will float, then it will slowly sink.
It's slightly, because water is because of oil frying, it expands in volume. So if mass is expands in volume, so density will be slightly less than say it has 90 kilograms. Specifically, it is about normal PFP is 1,200. I am ignoring there will be so much oil. So I am assuming that most of the oil is drained out. So CP is that one. So H is equal to, now you can calculate what this value is here. Can you go back to this one? So you get H into CP in the content. You have the value of H, then A is 155 to 10 to the power minus whatever that number is. Rho is 900, C is 1200, volume is already calculated. So calculate that one and you put the equation there. Okay? So then when you do all this one, you should get this number. That is simple division. You should be able to do that one at least. There is no algebra, there is no calculus involved. H times A is I have given you H, I have given you AS, I have given you rho, I have given you CP, I have given you V. So if you can't do that one, I'm sorry, I can't do it. H times AS divided by rho CP. That's what you have calculated. Take your calculators out and calculate that. I want HES, but in the child, I got in this one, this is 10. This one is what we have just calculated down to some 90. A is 155. This is 900. This is 1200. This volume is 9900 minus 6. So they calculate this one. That's what I do.
చాలా అయిపోతుంది క్యాల్కులేట్ తెచ్చుకోండి.
C, B, and H for E. C, A is the number which is notation, almost A is B is the load. Fourth line is the line coaches for the radio. The book is calculation. So 155 and 2 okay, the row is 900. C is missed C is specifically there. Anyone get this number? 0.30145. You got it? Are you copied from it? You will do it independently. You have got it independently. This is the number. This is my not 3.145. Okay? So this is the equation. Now we will solve this equation. In the row now initial temperature. No, ambient temperature 30 degrees. Ambient outside temperature. Ti minus T infinity 70 అవుతుంది. T temperature ఎలా అవుతుంది? T infinity again 30. T minus 30 divided by Ti minus T infinity should be equal to మనం ఇప్పుడు 50 డిగ్రీలో మనం వాటర్ తినొచ్చు అని అనుకుందాం. So that is I want this one to cool down to 50 degrees. So 50 minus 30 divided by 100 minus 30 that will be 0.286. So this number 0.286 కావాలంటే ఈ number దీన్ని ఈక్వల్ అయితే టౌ ఎంత కావాలి? Again, I don't know. 80% of people who don't know how to do it. Okay, people who know how to do it, they will do it. So this number is 0.286. 0.286 should be exponential of negative 0.4. I want to tell you what it is. How do you do that? Take natural logarithm of 0.286. So natural logarithm of 0.286 will be equal to negative 0.20145 times term. So this number will be negative, so ये negative cancel out. ये part of this number is divided by 0.5, then you will get out. Can you please do it? Take natural logarithm of 0.286. At least can you do that one? 50 minus 30 divided by 100 when that is equal to 0.286. Okay, how much is divided by 100 minus 30? I have rounded to 86, which would be 5 something. Just calculate that 50 minus 30 divided by 100 minus 30. Calculate that 50 minus 30 is 20, 100 minus 30 is 70. Can you do the calculation, please? 0.286. Okay? Take the natural logarithm of that, ln of that. It was the date to be some negative number. What's in that? So that negative number, that 145. But wait, tau will be in seconds. So you should get roughly about 8.5% tau.
ఓన్లీ టైం కాన్స్టెంట్ ప్రాసెస్ కంట్రోల్ ఇక్కడ కాదు. ఈ ట్రాన్స్ఫర్లో టైం కాన్స్టెంట్ కాదు.
నువ్వు లెక్క చేస్తే కానీ అర్థం కాదు. అన్లెస్ యూ you don't understand heat transfer unless you know at least simple algebra which is taught in 8th class, 9th class. Okay, will you get this number? 864.
Sir.
ఏంటమ్మా బోర్డు దిక్కు చూస్తున్నావు? మా ఇంటికి పెట్టి జగన్ పెట్టావా? నేను రౌండ్ ఆఫ్ చేసేసి పైసా ఓకే. దాన్ని డివైడ్ దాన్ని ఈ నెంబర్తో డివైడ్ చేయాలి. అది మైనస్ దానికి దాన్ని మినిట్స్లో కన్వర్ట్ చేసి Okay, guys, I think I'm running out of time. I'm taking too much of time because I just can't upload the camera. Okay. So you should get about 8 and 64 in time calculus. Okay. So that will divide the 16 by 14. So which actually means that technically, what I was taking out, which is 100 degrees, I have to wait for 15 days before I can eat. Okay. Normally you don't wait that long, so you flow across. By the time, what you are trying to do is with the edge, you are trying to increase to 20 or 30. So that will reduce your time. So when you increase this one, this number will increase. So that when you divide that one element, then this number will reduce. Okay, that's what we have. And in addition to that, there are few approximately at that temperature, radiation heat transfer also you can't neglect it. There will be a little bit of radiation heat transfer also because of the water will get a little bit cooler. And most often because you don't wait until 50, so you already what you do is you try to cool it by putting some chutney or sambar on it and cool it down. So you go for the little bit cooler. So if you will take this expression, if you plot it, this is what you will get. But I usually temperature 100 time, this is how the temperature will keep on reducing. I'll stop it at 50 degrees, so it will take about 864 degrees. So this is what is called in heat transfer. This is what is called the first order behavior because it's first order time. So it's the first order behavior way which you think is cool. Most of the heat transfer problems when they are cooling, they follow what is called the first order behavior. That's because it's a first order differential equation in time. So we have heat is very cold. It's only first order differential equation. So most of the temperature increases or temperature falls will follow that exponential decay. What is called that's because this is the exponential of this number. Okay. Okay, about what we have done is we assume that the entire water is one temperature, 100 degrees. Not only outer surface, inside also is 100 degrees. How are you sure this is 100 degrees or not? Unless you bite it, you don't know, right? Unless it burns your tongue. So there are some conditions under which only that we see it later. So when we are doing this one, then we assume that the water has got infinite thermal temperature gradients. So when there are now no temperature gradients are there, then we have to apply a different type of pattern of whether we can apply this in what is called a lump analysis. So we assume that the entire water is at one temperature. We are ignoring the temperature variation within the water itself. Unlike in the case of boiled potato, where you know that there is temperature variation inside the potato itself, here what are we assuming? Whether we are justified in doing that assumption or not, it depends upon certain criteria. I will take it up with them later in the next class. Okay, now I am stopping it here. From here I will go further. Let me repeat again. This is that your business to learn algebra, integration and other things, exponential, all these things. There is no time for me to teach your mathematics, integration and algebra and then teach transient theta. There is no time. And I have to go a bit faster. If I go faster, then actually it all will be like magic. So I beg you, I preach you, or maybe I even advise you, brush up your knowledge. If you fellows don't know d theta by theta, integration is ln of theta, you should be intelligent in theta. I'm sorry to tell you that. Similarly, if you take one number, say the side change, if you don't know that you can't. If you don't know what is surface area, no, is simply not acceptable. I'm not going to accept it. I'm going to go much faster, and you will go. I'm assuming that you know those numbers. I will assume that pi by 4 d squared is the surface area of a circle. Pi d is the periphery of the circle, and pi d h is the perimeter of the outer surface of a circle. Sphere 4 by 3 pi r. All these numbers I am expecting you to know. At least you know what is the volume if there is a brick which is a A, B and C. What is the volume? One side is A, another side B, another side B. What is the volume of that?
A into B plus C.
My God, at least you know that. Okay, next class I am going to teach that one. Okay, all right. Okay, I'll stop here. I know you fellows have a lot of questions. I'm happy to help you out. If anyone needs extra tutoring, explaining that, I'm happy to do that one. So far, no one has approached me. I'm happy to do that one. Provided it will be done. తెలుగు చెప్తాను అడగందా అమ్మాయి నా పెట్టదని మీరు అడగకపోతే ఏ టీచర్ చెప్పలేము ఓకే థ్యాంక్ యూ వెరీ మచ్